Yesterday, we talked about the basic idea behind a confidence interval, right? So the basic idea is that you're trying to trap the actual population proportion because we don't know it. We have a sample proportion, but not a population proportion. So we're using our sample proportion to estimate an interval in which we think P is with a certain level of confidence. So today I'm going to teach you how to actually calculate them because we didn't do that yesterday. We just kept talking about an example and talked about the idea. And so there's essentially 3 steps to a confidence interval. And the first step is to check the conditions every single time, right? If it asks you on the AP exam to construct a confidence interval, it's not going to say, oh, make sure you check your conditions like it does in our textbook all the time. It is part of it. It's part of the deal, okay? So the very first step in doing a confidence interval is checking your conditions. So you assume independence, and you can make a statement about that if you want to. You can say we assume that the blank are independent of each other. And then you have to check the randomization condition and the 10% condition. Now, randomization. If it does not say it's a random sample, don't say it's a random sample because you don't know. If it just says they're going to select 130 cars, then you need to think about, is that 130 going to be a good representation of the population or not? If it says that they did something via a internet poll, that's not a good sampling strategy, and that's not random. All right? So if it doesn't say it's a random sample, just don't say, oh, it's a random sample. Get out of that habit, okay? So either it says it or it's a good representation of the population as a whole for some reason. The 10% condition, right? Your sample size needs to be less than 10% of the entire population. We got that. Sample size. We need to make sure our sample size is large enough. In this case, since we're just talking about proportions and only proportions, then you have success failure. Is n times p greater than or equal to 10, and is n times q greater than or equal to 10? It's the number of expected successes and number of expected failures greater than or equal to 10. If one of them is not, then you can't move forward. Okay, so all these things have to be true in order to construct a confidence interval. That is step 1. So on your homework, when you try to show me your homework the next 2 days and in the next chapters, because this stuff is not going away. When you don't have the conditions for any of them, I'm going to start taking off points because you didn't actually do half the homework. All right? So every single time you got to check the conditions. Okay. Now, I said yesterday that the interval we're doing is called a 1 proportion z interval. Because we're dealing with 1 proportion, a normal model is our basis for what's happening, so z, and it's an interval, 1 proportion z interval. So there is a formula for that. We kind of tiptoed around it yesterday. But we have p hat, that's our sample proportion, plus or minus z star, z asterisk, and we'll talk about that in a second. That's a critical value, times the standard error. And the standard error was the estimate for our standard deviation we talked about yesterday. With the C fans, like the coral yesterday, we essentially said this. We had p hat was 0.519. Plus or minus, we did 2 standard errors because we were talking about 95%. That was an estimate because 95% confidence really isn't 2 standard errors if you want to get super technical about it. Okay? But so our critical value is going to be how many standard errors we are away from the mean, and that critical value is going to come from how confident we are. And we'll talk about that again in the next slide. How do we get that? Now, by the end of chapter 27, you will have 6 different intervals that you know about. So, on the AP formula sheet, they aren't nice enough to give you all 7 or 6 of them and name them for you. Like it doesn't say on the formula sheet, 1 proportion z interval, p hat plus or minus z times the standard error. It doesn't say that anywhere for you. They all follow the same format though. So, they give you a statement that you're required to, if you want to use, you're required to fill that in for yourself. So here's the statement on the formula sheet. It says for a confidence interval, you have the statistic you're dealing with. In this case, we're dealing with 1 proportion, so p hat. In future chapters, we might be dealing with 2 proportions, or a mean, right? Or a slope, Okay, so different things. In this case, it's proportion, so our statistic is a proportion. Plus or minus your critical value. That critical value, again, is based on how confident you are, and how you calculate it is based on what model you're using. Since we're using a normal model, we're going to use Z. In future chapters, we won't always use the normal model, so you can't always use Z. And then the standard deviation of the statistic is just your estimate for the standard deviation. It's the standard error in this case, which is the square root of P hat Q hat over N. Okay, so on a quiz, you can use the formula sheet. It's not going to give you the formula in green, but it'll give you the statement. It doesn't give you the standard error written out, but it does tell you the standard deviation for a sample proportion. You should remember that you're estimating, so you use P hat and Q hat instead of P and Q. All right, so that stuff is there for you to use. You should be smart about it and not just be like, what is this? Okay, so it's there for you to use. So we know, obviously, what P hat is, and then if we knew what P hat was, we could figure out the standard error. So the only missing piece then is what this critical value business is. So critical values. It's just the number of standard errors you want to be away from your mean. That, again, is based entirely on your confidence level. This is how you calculate that. You use inverse norm. Okay? If we want to be 95% confident, then if we talked about this yesterday, we're focusing on the middle 95%, right? We're centering it out, our sample proportion with the middle 95%. In order to find a critical value, we base that on a standard normal curve with a mean of 0 and a standard deviation of 1. Okay? So it has nothing to do with your information in your sample. Okay? But we want the middle 95%. And our Z critical value is our cut points for 95%. How many standard deviations you are from the mean. So if you're wanting the middle 95%, what percent is left over from 100? 5. And so what percent is left on each side? 2.5. And so we can use inverse norm to find what this cut point would be right here. Now, it's a mirror image on the other side, so we don't need to do it twice. One's going to be positive, one's going to be negative, and that's why it says plus minus in the equation. Okay? So if I want to figure this out, I would go to inverse norm. I type in your percentage as a decimal, so 0.025. I'm worried about the leftmost 2.5%. You leave the mean and standard deviation alone. Again, this has nothing to do with your sample. This is just to figure out the cut points. And you get 1.96. Which means over here you get positive 1.96. So 95% confident isn't exactly 2 standard errors. It's 1.96. All right? Now, it does not change from problem to problem because it has nothing to do with your sample, right? It's just a standardized amount. So every time you're 95% confident, and you're talking about a 1 proportion Z interval, your Z is always 1.96. I would commit that one to memory so you don't have to figure it out every time because you're going to use that one quite a bit. If I didn't want to be 95% confident, just to practice. Let's say I wanted to be 92% confident. Then what percent is left over on each side? 4. And so you would use inverse norm to find the cut point for 4%. So that's 0.04. It's negative 1.75. So that's what my critical value would be. It's 1.75. The two that you're going to have to use the most often are 95% confidence, which is plus and minus 1.96, and 90% confidence, which is plus and minus 1.645. Again, you can remember those. If you don't remember them, totally fine, because I just showed you how to find them. Right? I should be able to give you any percentage level of confidence, and you should be able to give me the critical value. Okay? If your book asks you, sometimes they ask you weird things, like let's be 98% confident. Well, then you could find that. Okay? So now we know all those pieces to that formula. So now you should know how to fill it all out. Questions about how to find critical values? Right, all the ones in the book and on the AP exam, they tell you how confident you're going to be, so all of your answers are the same. That's your critical value. How many standard errors you're going to want to be away from the mean. So you're going to multiply that in your formula we just talked about. This Z right here, that's the critical value. You're going to multiply that by your standard error, and you're going to add it and subtract it because you want an interval. So you have to have plus so much on one side and minus the same amount on the other side to get the interval. Other questions? All right, then I'm going to do some examples. The first example is just a review from yesterday. I gave you this statement at the end. All right? Like I said, there's essentially 3 steps to a confidence interval. One, you check your conditions. 2, you actually construct the interval. So you use the formula and you actually give me an interval percentages. And 3, you state the meaning of your interval. In context. So if I asked you to complete a confidence interval and you don't have one of these pieces, you can expect not to get full credit. It's just telling you. I tell you guys these things and then you don't listen. On the quizzes, you get mad when I take points off. I'm just saying. So you check your conditions, you do the math and construct the interval. The math itself is not hard. And then you state the meaning of your interval in context. We talked about step 3 yesterday. That's a sentence I told you you're going to have to know. So the first example I do, they're going to give us an interval. We're just going to interpret it for them. And then we'll do one all the way through. Okay. So, on the very first question, again, they already give us the interval. What fraction of cars is made in Japan? The computer output below summarizes the results of a random sample of 50 autos. Explain carefully what it tells you. So you already know it's a Z interval, because they tell you. You know what level of confidence they use, because they tell you. And they gave you the interval already. So all we're doing is explaining the meaning. So we're giving the last piece, that sentence. So in case you forgot, you want to start with how confident you are. So in this case, I am 90% confident. You're confident about trapping the true proportion. So I'm 90% confident that the true proportion, or the population proportion of, you give some context, so we're talking about the proportion of what? What about cars? Yeah. So that the true proportion of cars made in Japan is between, and you give the interval. So 29.9% and 46.9% or 47%. That sentence is always the conclusion, every time. You fill in how confident you are. You fill in the context of the question, and then you give the actual interval. Every time. Always how it ends. It never ends with just numbers like this. And then so again, on a quiz, if you end the question with blank percent to blank percent and you don't write a sentence, you're not getting full credit. I'm doing this for your own good because it's exactly how they're going to be graded on the AP exam. You won't get full credit because you didn't interpret what you said. So it's for your own good. All right, so let's do one all the way through, okay, from start to finish. So number 11 here, contaminated chicken. Great thing to talk about after you get lunch. In January 2007, Consumer Reports published their study of bacterial contamination of chicken sold in the United States. They purchased 525 broiler chickens from various kinds of food stores in 23 states and tested them for types of bacteria that cause foodborne illnesses. Laboratory results indicated that 83% of these chickens were infected with this bacteria that starts with a C that I don't know how to pronounce. Yes, we can call it campy lobster if you want to, but that's not what it says, I don't think. So part A says, construct a 95% confidence interval. Notice it doesn't say check your conditions. It just says construct a 95% confidence interval. So you check the conditions, that's part of the process. So, independence. Again, you can make a statement if you want to. You can say that we're assuming the chicken contamination is independent from chicken to chicken or something, if you want. All right, so we do need to check the randomization condition. So random. Does it say in this question anywhere that it's a random sample? No. But it tells you that they got the chickens from various kinds of food stores in 23 states. So we would say the chickens come from various stores and states. So this is a good representation of chicken. Right? They're not all from the same store. They're not all from Kentucky. Right? They're from a variety of places. So that's a good representation of chickens. 10%. What is our sample size? So it's 525, less than 10% of all broiler chickens. They sell those suckers all day long at Kroger here, all day. So I'm sure that whatever the entire U.S. says, way less than 10% of I believe it.
I don't believe it.
I do.
I believe they're actually selling small pieces of whale.
They're not selling small pieces of whale. Doesn't make any sense. All right. Sample size. We need to... All right, friends. Back on track. So success, failure. What do we check for this? So N is 525. What's P? And we don't actually have P. We have a P. We're going to use that anyway. So what's P hat? 0.83. And that means we need to also that 525 times 0.17. Both of those are greater than or equal to 10. You would need to show the values. If someone wants to compute those for me on their calculator, that'd be great.
But you got it.
All right, so both those are greater than or equal to 10, so we're good. Now, I'm getting ready to add in a sentence to your conditions. Pretty much everything we do, every chapter, every interval, every hypothesis test, everything we do, it always starts with checking the conditions. And then, after we check the conditions, we need to state what we're doing for anybody that's following our work. So in this case, we've only learned one thing. One proportion Z intervals. That's the only thing we know how to do. Right, so after a while, we're going to have like an arsenal of different types of intervals and tests, and you to identify what you're doing. So I'm adding in a sentence for you. Today, the sentence is always the same. And the next chapter, then you'll have two things. You'll be like, okay, are we doing an interval or are we doing a test? You have to identify which one you're doing. You write it out, okay? So each chapter, we're going to add in something that it could say. But in this case, it's always going to be the same. So you always need to write the following sentence or something along the lines of, because the conditions are met. We or I can construct a one proportion Z interval in this case this part will be interchangeable depending on what we're doing. Okay, but you always write, because the conditions are met, we're going to do this. All right? Questions about that? True. Yes, so if the conditions are met, you say because the conditions are not met, we cannot construct an interval, we cannot complete a hypothesis test, we cannot do whatever. Okay? Perfect. So you're already in the habit, right? We should need to always state what we're going to do. All right, so that is step one to doing a confidence interval, checking your conditions. Step one, check. Step two, we actually construct the interval. We do the actual math. So I'm just going to keep writing in the margins over here. So we have a formula now. It says p hat plus or minus the critical value times the standard error of p hat. So what is p hat in this question? 0.83. The question tells us we want to be 95% confident. So either you commit to memory that your critical value is 1.96, or you use inverse norm in your calculator every time until you remember. Okay? And then we need a standard error of p hat, which is just the square root of 0.83 times 0.17 divided by 525. Okay? Okay, so I have filled in the formula. You should show this work because it's not that complicated. Right? It's not like you're filling in some crazy formula. Like, you can show that much. If you show that much and then make a computational error in your calculator, they won't take any points off. So I would show that. Those of you that like to do the bare minimum, stop it. All right, so I got 0.83 times 0.17 divided by 525. Square root of that is 0.016. I need to multiply that by 1.96. So I essentially have 0.83 plus or minus 0.032, right? And then so for the interval, I would do 0.83 minus that and 0.83 plus that. So my interval is 0.797 or 79.7% to 0.862 or 86.2%. So that's the second step. Construct the interval. Got an interval. Check. Third step. Interpret the interval. Can't stop there. I am. We are. Whatever you want to say. 95% confident. That the true proportion, what are we looking at in this case? What are we talking about? The true proportion of infected or contaminated chickens. Yeah, I kept saying infected this morning, but I guess technically it's contaminated. They're broiler chickens. They're dead. They've already cooked. I don't know.
Yeah, because they weren't broiled from a bird.
Oh my gosh. All right, 95% confident the true proportion of contaminated chickens is between 79.7% and 86.2%. I know that seems like a lot, but when you're doing it and I'm not taking like 5 seconds to explain everything and then talk about it and then get sidetracked by the yahoos over here, then it doesn't take that long. I know. All right, questions about what I just did though? So I hit 3 steps. That was all for constructing a confidence interval. Now, listen very carefully. Your book, at the beginning, just like it always does, the first few you're going to do, the book asks you to do it all in steps. So like the book will say, do a confidence interval, make sure you check the conditions. And it'll say, interpret your interval, or explain what your interval means. Well, so if you do it all, you can go back and just label in parts, oh, this was A, this was B, or C, or whatever. But I'm trying to get you away from that because at no point really in real life or on the AP exam are they going to give you multiple parts where they ask you to do each of those things. They're just going to say construct a confidence interval, and you're supposed to know what that means and what that entails. Okay? So, we answered A, and technically we already answered B because it says explain what your confidence interval says about the chicken sold in the U.S. I already interpreted the interval. Okay? Now, C, this is just a good discussion question here. A spokesperson for the U.S. Department of Agriculture dismissed the Consumer Reports finding, saying that's 500 samples out of 9 billion chickens slaughtered a year. With the small numbers they tested, I don't know that one would want to change one's buying habits. Is this criticism valid? And explain. What's the entire point of a confidence interval? To trap whatever P is. So I'm 95% confident that between 79 point whatever and 86 point whatever % of these chickens are contaminated. Yes. You eat contaminated chicken. So is the criticism valid? Not really. It doesn't matter what our sample size was. If all our conditions were met and I've tried to trap P, yeah, it's based on one sample. But I'm 95% confident about this interval. That's pretty confident about the interval.
It is.
All right, so, and it's still, the interval itself is still high. It's from 79% to 86%, so it's still rather high. So I would say my interval, I would go with that, not with this person who is clearly trying to save his job. Okay. I'm not going to do number 12, but again, this is what they normally look like. They ask you the question, but then it splits it up for you. Look, it says A, it says, oh, check the conditions. B, construct the interval. C, explain. We need to get away from that.
Okay.
Okay, so try to get away from that. Okay. Just write it all out and then go back and label the parts. Because again, it's not going to tell you those things. All right, a few more side notes, and then I'll be done. And 15, it says the Paralyzed Veterans of America is a philanthropic organization that relies on contributions. They send free mailing labels and greeting cards to potential donors on their list and ask for a voluntary contribution. To test a new campaign, they recently sent letters to a random sample of 100,000 potential donors and received 4,781 donations. So they don't give you a P hat in this question specifically. Like they don't come outright and say, here's the % of people that donate. They do give you enough information to figure out what P hat is. How would I figure out P hat? Just divide. Okay? Then it says to create a confidence interval, blah, blah, blah. I've already done all that. Okay? I've checked the conditions, whatever. Here's my interval. I could interpret it. That's not really the point. We already know how to do that. I'm not trying to do that again. It takes forever, right, for me to get through it. So here it is. That's the interval. Part B, though, says, a staff member thinks that the true rate is 5%. Given the confidence interval you found, do you find that percentage plausible? 5% is right outside of our interval, like barely.
Yeah.
And I'm 95% confident, so 5% may be plausible, right? Because this is based on one particular sample, it's one campaign. If they change this, though, to like 10%, is 10% plausible? No. Our interval, I'm 95% confident, it's like 4.6% to 4.9%. That's nowhere close to 10%. So I wouldn't think that's plausible based on my interval. Okay? So you can use your interval to answer questions as well. Okay? Before I give you the homework, some things to keep in mind. And if you wanted something on the homework that we need to talk about again tomorrow, we can. A lot of them are rather straightforward questions. However, one of the questions starts talking about margin of error and wider or narrower and stuff. Again, I'm going to keep asking you those questions. In the formula, I need to erase all this. I've like drawn all over it. In the formula, if it says to compute the margin of error, the margin of error is just all this part. It's the plus or minus whatever. That's the margin of error. So if it says compute the margin of error, it's not asking you to do a whole interval. It's just asking you to compute the plus or minus part. Does that make sense? You just do the critical value times the standard error. That's the definition of margin of error.
Okay, so margin of error is like only one side from the test?
It's plus and minus, the same amount.
Okay. Yeah. So it'd be like,
Right. It's like how much wiggle room are you allowing yourself? Okay, so don't get confused by that terminology. It just means that part.